All right, this video is going to focus on two types of factoring. Factoring out the greatest common factor, factoring a trinomial with the coefficient of 1, and factoring and then solving. This is all Algebra 1, Chapter 7 for my class. So factoring out the GCF, if we look at two numbers like 8 and 6, these both have a greatest common factor. Factors are numbers that you can divide both of them by. So a common factor, the greatest one, would be the biggest number that they both can be divided by. So the factors of 8 are 1, 2, 4, and 8. Because 1 times 8 is 8, and 2 times 4 is 8. And the factors of 6 are 1 and 6, and 2 and 3. So the greatest number they have in common is 2. So we can divide them both by 2. So that plays out in our factoring if we have something like this, 6x squared plus 8x. And we need to factor out the greatest common factor, and we also have an x in both terms. So what we're going to do is we're going to say our greatest common factor is 2x. They both have an x, and they both have, they can both be divided by 2. So when I take 2x, I want to know, I'm like reverse distributive property here. So I want to know 2x times what will give me 6x, and 2x times what will give me the 8x. So let's engineer that distributive property there. So 2x times 3x will give me the 6x squared, and then 2x times 4, when I multiply those two together, we get 8x. And that's how we end up with 6x squared plus 8x. So that's our factorization. It's 2x times 3x plus 4. And the best way to get better at this is just practice, practice, practice. So let's look at another example. How about 21x cubed plus 28x squared? Well, if we look at 21 and 28, 21 is 1 and 21, and it's 3 and 7. And 28 is 1 and 28, 2 times 14, and 4 times 7. So our greatest common factor here is the 7. So I can factor out that 7 in front, and then, oops, I want a number or a pen. Factor out that 7, and then if we look at our variables, we have x cubed and x squared. So we're going to take out the x squared. That's what they have in common, because x squared times x will give me x cubed. So I can take out an x squared. And then again, we want to know 7x squared times what will give me the 21x cubed, and then plus what will give me the 28x squared. So it's 7 times 3 gives me 21, so that's 3, and then x squared times x gives us the x cubed. That gives us 21x cubed. And then 7x times 4, 7 times 4 will give us the 28, and x squared is already there, so it's just plus 4. So my final factorization is 7x squared times 3x plus 4. Let's look at one with negatives. Let's see, 25 minus 10x. Okay, 25 minus 10x. Well, they don't have an x in common, but 25 and 10 both have a common factor of 5. So we're going to take that 5 out, and it's 5 times what gives me 25. That answer is 5. And 5 times what gives us negative 10x, and that's going to be negative 2x. And that's my factorization, 5 times 5 minus 2x. And that's factoring out your greatest common factor. Now then, when it says to solve, these problems will be equal to 0 instead. And so we can take each parentheses. We have what's called the zero product property, that tells us if the product of two numbers, 7x squared or 3x plus 4, is equal to 0, then either 7x squared equals 0 or 3x plus 4 equals 0. And so that means we get two possible answers here. If I solve this, divide by 7, and then x squared equals 0. Well, the only thing squared that equals 0 is 0, so x equals 0. And then here I can subtract 4, solve my two-step equation. So 3x equals negative 4, and divide by 3. So x equals negative 4/3. So you have two answers here, 0 and negative 4/3. And then with this one over here, this does not, the 5 doesn't have a variable, it's just 5. Because we only have one variable here, so we're only going to end up with one answer. I don't need to worry about that 5. I can just take 5 minus 2x equal to 0. Now if there was an x on the 5, then I would write an equation, 5x equals 0, but there's not here. So I'm going to subtract 5, and negative 2x equals negative 5. Divide by negative 2, and x is positive 5/2. We only get one answer because we only had one variable. The next factoring is factoring x squared plus bx plus c with a no coefficient. So factoring is reverse foiling, basically. So it comes from, say I have x plus 3 times x minus 4. This I multiply out, I get x times x is x squared. I get x times negative 4 is negative 4x. I get x times, or I'm sorry, 3 times x. 3 times x is plus 3x. And then I get 3 times negative 4 is negative 12. And when I put this together, I get x squared minus x minus 12. And I'm color coding this because we're looking for, when we're factoring, we're going to go this way. I want to write the factors, the two binomials that it multiplies. And so we're looking for two numbers that multiply to negative 12 and add to negative 1. So we want what two numbers do both of these things. And oftentimes we organize that into this box. So x squared minus 7x plus 12. We put it in this magic x, we call it. We put our 12 on top and we put our 7 in the bottom. And we ask ourselves, what two numbers multiply to 12 and add to 7? It's negative 7. And we get negative 3 and negative 3. Or sorry, negative 3 and negative 4. And so to put that into our factors, we write our parentheses, and it's x and x, because x times x gives you the x squared. And then it's x minus 3, x minus 4. And if we were to multiply that back out, we should get what we started with. Let's look at another one. X squared minus 20x, or plus 20x plus 100. So we want to know what two numbers multiply to 100 and add to 20. So you have to think about the numbers that multiply to 100, 2 and 50, that can't add to 20. 2 times 50, that's not going to work. 4 times 25, that's not going to work. 5 times 20, that's not going to work. 10 times 10, 10 times 10 equals 20 when I add it, and when I multiply it equals 100. So 10 and 10 are my two numbers. So my factor is x plus 10 times x plus 10. What if we have something like x squared minus 13x plus 42? Again, we're looking for two numbers that multiply to 42 and add to negative 13. And if I think about the numbers that multiply to 42, okay, in your head you should be doing 1 times 42. That doesn't work. 2 times 21. That doesn't work. 3 times 14. That can't add to 13. How about 6 times 7? Okay, there we go. There's our two factors of 42 that could add to negative 13 if they are both negative, negative 6 and negative 7. And you have to pay attention to the sign. If the top is positive, and if it's multiplying to a positive and adding to a negative, then they're both going to be negative, because the only way to multiply to a positive but add to a negative is to have two negative numbers. And if everything's positive, then they're both going to be positive. X minus 6, x minus 7. If we have something like this, x squared minus x minus. So if the constant term that multiplies is negative, then we are looking at having a positive and a negative number. And you have to pay attention to which one you make negative, because that is going to determine what that middle term ends up being. So if it's negative 6 and negative 1, the general rule is that it's going to, the bigger number is going to have the same sign as this on the bottom. The bigger number is going to have this sign because when I add them together, the bigger number gives the sign on the answer. So what two numbers multiply to 6? 1 and 6, 3 and 2. How can I make that equal to negative 1 if I have a negative 3 and a positive 2? So that's x minus 3 and x plus 2. Now, what if it says solve? Okay, and we have x squared plus 20, let's say 2x minus 15. I want to know what two numbers, and that should say equals 0. I want to know what two numbers multiply to 15 and add to positive 2. Add to 2. We're looking at 1 and 15 and 5 and 3. If the 5 is positive and the 3 is negative, I get a positive 2. So I have x plus 5 times x minus 3 equals 0. And I can set each parentheses equal to 0 to solve it. I'm just going that one extra step when it says solve. When it says factor, I don't have to go. When it says factor, my answer is just the factors. When it says solve, I need to say what x equals. X equals negative 5 and x equals 3.